So now we are going to solve compound inequalities. All right, so we want to solve and write the final answer in interval notation. So first of all, before anything else, we want to be able to solve each of the inequalities. So let's do that now. Okay, so multiply by 2, subtract the 4, and divide by -1. Again, remember, when you divide by a negative, you must switch the inequality sign. All right, let's solve the other inequality. So multiply by -3. Again, because I'm multiplying by a negative, I must switch the inequality sign. Add the 7 and divide by 2. Now, because this is an AND problem, this is an intersection. So it is where these solution sets are going to meet or intersect. So let's put these on a number line. So again, where do they intersect? Again, it does not look like that they're going to intersect anywhere. So then somebody might say, well, how about a 2? The problem is 2 is not a solution here, and it's not a solution here. So if they don't intersect, and 2 is not a solution for both, this is a no solution. Okay? So what that means is I could either write this, which is what is called the null set, or this symbol, which is called the empty set. But there is no solution to this inequality. Okay, let's go to the top right, solve each inequality. All right, so easy enough to solve. So now let's put each of these on a number line. Now remember, this is an OR statement, so this is a union problem. Okay? So I can be either in the black or in the blue. So if I want to redraw this, and I can, what is the interval that is in the black or the blue? Well, the black starts at -2. It's not a solution there, but it's a place to start. So that's a parenthesis. And both the black and the blue go to infinity, and we know we put a parenthesis after that. So that is the solution to this. Okay, now let's take a look at these two here. Now, notice you do not see the word and or. This is certainly a compound inequality. This is going to be an and. Now, how do I write this out as two separate inequalities? Well, that's this. Right? That's going to be one inequality, and that's going to be the second one. Okay, so I can solve for each of these. So that's a is greater than or equal to -4. Okay, so I have a is greater than or equal to -4, and a is less than 28. Okay, so let's put these on. So now again, this is the intersection. So again, where do they overlap or intersect, both black and blue? It's that particular region in red. So -4 is on the top and on the bottom, so it's here. 28 is certainly on the top, but not on the bottom. So 28 is not part of the solution here. Now, I would like to show another way on how I can solve this same inequality. So I'm going to go to another page here, and I've already taken the time to rewrite this as such, except I'm going to put another side equal to there. Now, I could solve this just exactly the way it is by getting a all by itself in the middle. So what do? Add the 4, and then multiply every single part by 2. Well, negative 4 is less than or equal to a, which is less than 28. You know what that looks like. We talked a little bit about that earlier. Now remember, that's telling me a is greater than or equal to negative 4 and less than 28. So there's our answer with this. If we go to the previous page, we can see that the answer is exactly the same. So you have two different ways on solving this compound inequality. It's, remember though, it is and, not or. Okay, so let's solve this last compound inequality. I'm going to leave it as one big one instead of separating. So I'll subtract the 3. And then I'm going to divide everything by negative 2. Now remember, the inequality signs do change. But remember what this means. X is greater than or equal to negative 5 halves and X is less than 15 halves. So let's make sure that this actually makes sense here. So let's put a number line. I'll do it in a different color. So negative 5 halves, I better be greater, and less than 15 halves. In this case, that makes sense. So then I can rewrite it in interval notation as such.